today's lecture we are going to discuss about electron configuration and orbital notation diagram. Our topic name is electronic configuration and orbital notation, or you can say orbital notation diagram. Okay, so first of all let me tell you what is electron configuration as we discussed in the last two videos. Link is in the channel, part 1 and part 2 video, watch that. Now this is the part 3. Let's start with, I am writing here again above principle for our revision. 1s, 2s, 3s, 4s, 5s, 6s, 7s, 2p, 3p, 4p, 5p, 6p, 7p, 3d, 4d, 5d, 6d, 4f, 5f, 6f. Then this sequence is 1, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 7, 6p, 7s, 5f, 6d, 7p and 6f. Next task is, suppose let's take an example, electronic configuration of nitrogen. We will draw electron configuration and orbital diagram also. Okay, nitrogen. So as we all know, nitrogen's atomic number is hydrogen, helium, lithium, beryllium, boron, carbon, oxygen, carbon, nitrogen, oxygen, fluorine, neon. So nitrogen's atomic number is 7. So 7 means we have to complete the number 7. So first orbital is 1s. And we also all know limit of s block is 2. P block is 6. And D block is 10. So 1s, 2. Okay, after 1s which orbital is there? 2s. So 2s also contains 2 and then 2p. So we have to complete the number 7. So 2 plus 2, 4. So how many remaining? 3. So this is the electron configuration of nitrogen. Then there are two principles. One is Pauli's exclusion principle and second one is Hund's principle. And that principle are very important for this molecular orbital diagram. So I am posting the principles here, Pauli's exclusion principle and Hund's rule. Okay, so now we are applying that rule directly. Listen carefully to draw the orbital diagram. Suppose 1s, so this is the first subshell for 1s, this is the subshell for 2s and this is for 2p. As we all know, 2p contains p block has 6 electrons. P block can add 6 electrons. Pauli's rule says that the electrons are there in the opposite spins. Electrons are there in opposite spin, and in one subshell it contains 2 electrons. So in 1s2 there are 2 electrons. So one electron is like this and another one like this, opposite spin. Okay, 1s2, 1, 2. Then 2s2, 1, 2. And now Hund's rule said that in this subshell, all these orbitals should get 1 electron each first, and then if some electrons are remaining, then they will start pairing. It means, suppose imagine you are sitting in a bus. Okay, suppose suppose this is a bus and there are 3 seats. Okay, this is our bus and there are 3 seats, 1, 2 and 3, and 2 passengers can sit in these seats each. So which seats will occupy first? Of course the window seats. So this is the window seat rule, that 3 electrons should be here and then the pairing will be done. It means, suppose if I wrote like this and this is empty, then this structure will be wrong and this will be the correct according to the Hund's rule. So finally nitrogen's orbital diagram is like this. So I am writing here 1s2, 2s2 and 2p3. This is the correct method to write the orbital notation of nitrogen. Okay, we will take one more example so you can understand the concept more precisely. After nitrogen, oxygen, let's take an example of fluorine. I am writing here electron configuration of fluorine. What will be the electron configuration? 1s2, then 2s2, fluorine's atomic number is 9, then 2p. So what we have to complete? 2 plus 2, 4, and how many remain? 5. So this is the electron configuration of fluorine. Okay. How will we, again I am telling the rule, how will we cross check the electronic configuration is correct or wrong? We have to count these numbers, 2 plus 2, 4, 4 plus 5, 9, and this atomic number. If these numbers match, then the electron configuration is correct. This is the sequence for writing the electron configuration. We must write 1s first, then 2s, then 2p, 3s, 3p, 3d, 4, 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p and 6s. And the capacity of the each block is, for S block is 2, for P block is 6, D block is 10 and F block is 14. Capacity to acquire the electrons. These are the capacities. So S block will, 1s will occur only 2, 2s will occur only 2. Now how many remaining? Only 5 remain because our atomic number is 9. Means number of electrons are 9. So 2 plus 2, 4 plus 5. So this is the electron configuration for fluorine. Now we will draw the orbital diagram. This is 1s, this is for 2s and this is for 2p. So 1s2, 2s2 and now 2p5. So 1, 2, 3, 4 and 5. This is the correct method to write the electronic configuration and orbital notation. Now take a screenshot. Okay, let's move forward to the next concept. Next example. Let's write example of Fe. So as we all know, iron's atomic number is 26. So its electronic configuration will be 1s2, then 2s2, 2p6. How much are 2 plus 2, 4, 4 plus 6, 10. After 2p, 3s2, 3p6, 2 plus 2, 4, 6 plus 4, 10, 10 plus 2, 12, 12 plus 6, 18. After 3p, 4 is 18 plus 2, 20, and now 3d. You have to complete the number 26. 2 plus 2, 4, 4 plus 6, 10, 10 plus 2, 12, 12 plus 6, 18, 18 plus 2, 20, 20 plus 6, 26. So this is done. Now our next task is to draw the orbital diagram. 1s, 2s, then 2p, 2s, 2p, then 3s, 3p, 4s, and 1, 2, 3, 1, 2, 3, 4, 3D. 1s, 2s, 2p, 3s, 3p, 4s, 3d. Now 1s2, so 2 electrons are there, 1, 2. 2s2, again 2 electrons are there. Then 2p, 6. How will they complete? 1, 2, 3, and then they will pair. 4, 5, 6. Then 3s2, 1, 2, 3p6, again 1, 2, 3, 4, 5, 6. Then 4s2, 1, 2, and then 3d6. So it will feel like 1, 2, 3, 4, 5, and then the 6th. So this is the correct method to write the electron configuration. So let's count the number 26 or not. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. This is the correct method to write the electron configuration and orbital notation. So if you have any doubts, ask in comments, and keep watching the video and keep sharing the video. Thank you so much.